In this video, we are going to discuss the integer division on the DT based. The integer division is nothing but it is a kind of operation which is used to implement in the hardware or the software. While we are performing this operation, we need the two integer numbers. The one will be act as the dividend and another will be the divisor. After performing this operation, division operation, we will get the two values. One will be called as the quotient and another will be the remainder. We can consider we are having the multiple problems, like if you are having a 13 mangoes, if you want to split it in equally to the two persons, we will get the one remainder. Likewise, if you are going to divide the salary 8 rupees for a 3 persons, in that also we will get the remainder as 2. So in the particular like this we will have a multiple problems. This problem how it is going to handled by the hardware or computer. Okay. For handling this types of problems, we are having the basic operations in ALU like shift, subtract and add. With the help of these three basic operations in the computer, we are going to solve this kind of problems with the help of algorithm, restoring and non-restoring algorithms. These algorithms which is used to find the suitable solution for the integer divisions without omitting the decimal values. Okay. For that we are having the multiple methods. Okay. The methods, it will be the kind of a implementation part, so it will comes under the ideate. The methods are different types of approaches which is used to solve this kind of problems are repeated subtraction, then shift and subtract algorithm, or it may be a hardware divider circuits. These three types of approaches, we can adopt any one type of methods to solve the problem like the integer division. Okay. Then in this, we are going to implement this problem through the restoring algorithm. Already we discussed that we are having the two types of algorithms which is used to solve this integer division problem. Okay. In this, first we are going to discuss the restoring division algorithm. While we are going to perform this operation through this algorithm, we need a three registers, M, Q and the A register. Initially, the A register, it is used to load the divisor value and the Q is used to store the dividend value. And the A initial, it will be set to 0 and the final result again it will get stored in the A and Q. A is used to hold the remainder and Q is used to hold the quotient part. Steps which is used to follow to solve the restoring algorithms are: the first step, first we have to do a left shift of values which is stored in the A and Q. But the bit position to be shifted is 1. Then next we have to do the subtraction. We have to subtract M from A and we have to restore the value of A. Then if the A sign bit is equal to 1, then we have to set Q not equal to 0. Then we have to reset the value of A. Then A equal to 0, then we have to set Q not equal to 1. Vice versa, we have to do it. The A it's means for the sign bit. Then next we can consider this example 8 divided by 3. Okay. This number we are going to do a integer division through the restoring algorithm. The binary number for 8 is 1000 and for 3 is 11. Right? Already we know that it is the first bit is 1, 2, 4, 8. Likewise, if it is 3, then 1 plus 2 is 3. Then next, if we are going with the binary division of this particular divisor should be greater than this dividend 8. 8 we are having only the 4 digit. That 4 bit, but the divisor should be a 5 bits. Then, this is the normal division method which we have studied in a paper and pen method. 8. If we are divide 8 by 3, 2 3s are 6, then the balance is 2. This 2 it is a quotient and this 2 it will be a remainder. Likewise, we are going to do it in the binary method. The binary number for 8 is 1000. We are going to divide with number 3. 3 is 2-digit number. 3. Then if you consider first this 2 bit, after this 2 bits we have to include multiply and include the value, and we have to get subtract the value and write the remainder. Here also both the value we are getting 0 2. Here also 0 2. So we are getting the same value which we have done through the paper and pen method. Then if we are going for that restoring method, first we have to convert that m value. If we are going with the addition, then there is no need to take a 2's complement. Then if we are performing a subtraction, then we have to take a 2's complement of that m. First we have to take the 1's complement. Then we have to add 1 in order to make it as a 2's complement number. Then this will be a 1 0 1 1 1 will be the 2's complement of the M register. Value is 3. It is written in 5-digit number, binary number. Then the 2's complement of number already we have done. That number is just straight away I have written here. Initially, the register A, it will contains the only the zeros, and the register Q, it contains the dividend number. The dividend is already discussed that it is a number 8. We are going to do a 8 divided by 3. This binary number it represents the 8. Then next what we are going to do is we are going to perform the 4 types of operation. First we are going to perform a shift left. Then after that we are going to perform a subtraction. After performing a subtraction, based on the sign bit, the last bit of A, we are going to set the Q0. Then after that we are going to restore it. Okay. If the Q0 is 1, then it will be reset to 0, then we will perform restore. If this is 0, just we will reset the value as 1, but we will not perform the restore operation. Okay. So shift left means this 0 will be goes out, then this will comes here. So this one it will be comes here. Okay. Then it here in the last position in Q0, it will create a empty hole during the first cycle. Then next what we are going to do, we are going to do a subtraction. We are going to subtract m with a. This is m and this is the a. We are going to subtract this. If we are going to perform a subtraction, we have to consider the 2's complemented number. The 1 plus 1 is 0, carries 1, 1, 1, 0, 1 plus 0 is 1, 1 plus 0 is 1, then here also 1. Here the sign bit is 1. Then next what we have to do, we have to set the Q0 because we have created a hole here, right, after shifting the 1 bits left. So we are going to fill this vacant position. So here if it is 1, we have to write it as 0. Right. After setting this Q0 position, we have to reset it. While if we are resetting it, the 2's complemented number, it should be returned to normal number. 0 0 1 1, right? 3. If you are adding this numbers 0 plus 1 1, 1 plus 1 is 0, 1 plus 1 0, 1 plus 1 0, 1 plus 1 is 0, right? That particular remainder one we will skip, we will not consider. So the steps, the 4 steps which we have done is called as the first cycle of process. The number of cycles will be repeated based on the number of bits in the dividend. Next, after restoring, again we have to perform a shift left operation. If we shift left, this will goes out. Then this 3 0 1 will come here. This 0 will come here. Then this 2 0 as such it will comes here. Then created previous cycle value also it will place here. Then for this cycle it will create a new vacant position here. Then after shifting we have to perform the subtraction. The subtraction, if we are subtracting, then we have to write the 2's complement number. After writing that, we have to do a operation. If you perform a addition operation, then all the bits will be set to 1. Then here 1, we have to set the Q naught as 0. After setting the Q naught position, we have to restore the value A and Q. Restore the value. In this cycle, the dividend position to Q naught is replaced. Next, after performing this, next what we are going to do means, again we are going to do a shift left operation. If you write this number, same numbers 0, 0, 0, 1, 0, then here 0, 0, the replaced value of previous cycle, second cycle to this value. If you shift left this value, then this 0 will come here, this 0, 1, 0, then this 0 will come here, then this 0 is replaced here, and during the third cycle, the third vacant position will get opened. Then next we have to perform the subtraction. Subtract m with j. If you subtract this to perform this addition, then we will get this value. 1 plus 0 is 1, 0, 1 plus 1 is 0, carries 1, 1 plus 1 is 0, again carry 1, 1 plus 1 is 0. The remaining one we will skip. Okay. After performing this subtraction, we have to set the Q naught, right? Here Q naught is, here the A is 0. If A is 0, then we have to fill with the value 1. It is filled. Okay. Then after this, here there is no need to restore the value, that already we have discussed, right? Just we have, if the A position is, sign position is 0, just we have to perform the shift alone. We should not do the addition or the restore operation. So this thing will be done at the third cycle. Next, after performing the setting of Q naught, next what we have to do? We have to do a shift left. This 0, 3 zeros will come here. The 1, then this 0 it will be shifted here. Then the filled Q positions will be shifted here, and it will create the empty vacant position at Q naught. Next, we have to perform the subtraction of m. If you want to subtract, then we have to write a 2's complement of 3, 1, 1, 1, 0, 1. If you perform a addition, then we will get all the bits will be set to 1. Here, if you consider this sign bit A, it is 1. Already we know that if the sign bit is 1, then the Q naught will be set to 0. Then we have to restore the value. Restoring means we have to add the normal 3 value. 1 plus 1 is 0, carries 1, 1 plus 1 is 10, 10 plus 1 is 11, 1, again carries 1, 1 plus 1 is 10, again carry 1, 1 plus 1 is 10, again carry 1, 1 plus 1 is 10, balance 1, we will ignore that. So, this will be done at the fourth cycle. Now, all the bits in the dividend is replaced. New values are replaced. So, these values will be stored in the remainder and quotient part. The A will be, already we discussed, right? The A will be stored in remainder and Q will be stored in the quotient part. If you perform this operation, we have to get the value 2, right? Remainder 2 and the quotient also 2. 1, 2. Here also 1, 2. We are getting the same value which we are done at the using of paper and pencil method. Thank you.